So one of the things I told you when we were graphing the reciprocal function and the reciprocal square function is that the asymptotes define the behavior of the graph. They are going to be the most useful piece of information we have when it comes to graphing rational functions. So the previous video we found vertical asymptotes. This video is about horizontal asymptotes. There are two situations you are responsible for in college algebra. The first is if you come across a rational function where the degree of the numerator, meaning the top, is less than the degree of the denominator. Now, in case it's been a while and you don't know what degree is, the degree is the highest power. The highest power of the top is 1, x to the first. The highest power of the bottom is 2, x to the second. So this is the situation where the degree of the numerator is less than the degree of the denominator. When you have that situation, then it is very straightforward. The horizontal asymptote will always be y equals 0. Okay? So anytime the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. The other situation that you might encounter is the degree of the numerator equals the degree of the denominator. Like this example, I have 2x plus 1 over x minus 5. The degree of the top is 1. The highest power is x to the first. And the same thing in the bottom, x to the first. When that is the situation, the way that you find the horizontal asymptote is it is the ratio of the coefficients in front of the highest power term. So what I mean is, here's my x to the first. The coefficient is 2, so the numerator is 2. Here is my x to the first. The coefficient is 1, so 1. So that means the horizontal asymptote here would be 2 over 1. So I'm going to just write on the little whiteboard that I have here 3 more examples. After I've written them down, I would recommend pausing your video and then seeing if you can figure out what the horizontal asymptotes are for each of these situations. So here we go. The first one is going to be, let's say that I have this. We want the horizontal asymptotes for each of these. So if I have x squared minus 5 over 3x squared plus 2x minus 9. That's going to be the first example. The next one is what if I have 3 minus 4x over x plus 1. And then the third example is going to be x squared minus x plus 2 over x cubed minus 5x plus 2. So pause the video, determine what the horizontal asymptote is for each of these, and then press play, and you'll see me work these out. So the way it is, this is the situation where the degree of the top, x squared, is the same as the degree of the bottom, x squared. They both have degree 2. So when the degree is the same, the horizontal asymptote is y equals, and I'm going to make the ratio of those coefficients. So the coefficient in front of this x squared is a 1. And the coefficient of this x squared is a 3. So y equals 1/3 would be the horizontal asymptote. And then this one is the same situation. I've got a power 1 here, a power 1 here. So it's the degrees are equal. So the horizontal asymptote is going to be the ratio. So this coefficient is -4 over this one is 1. So that is the line y equals -4. And then the last one, this is the situation where the degree of the top is less than the degree of the bottom. X squared, that's degree 2. X cubed, that's degree 3. So this is y equals 0. And so what I would like you to do, because we are going to graph things just like these, and the horizontal and vertical asymptotes tell us a lot about the graph, I want you to go through all the homework in section 5.2 and find all the vertical and horizontal asymptotes. So that way, when I tell you the other steps to graphing, you're already half done with the problem.